Welcome to Research Rundown. Today we're diving into a fascinating study on the impact of climate change on global food systems. Joining me are two experts with differing perspectives on this critical issue. First, we have a renowned environmental economist who has spent years researching sustainable agriculture and its effects on economic growth. She's known for her optimistic approach to finding solutions in these complex problems. On the other side of the debate is a seasoned climate scientist with a reputation for skepticism towards some of the more ambitious claims made by researchers in this field. He'll be bringing his critical eye to our discussion today, questioning the methods and assumptions that underlie in this episode. We'll examine the key finding that has sparked debate among experts: the potential for climate-resilient crops to increase global food production while reducing greenhouse gas emissions. But can these new technologies truly make a dent in the problem of hunger and poverty? Let's dive in and hear from our expert debaters as they weigh in on this crucial topic.
Ladies and gentlemen, I'm thrilled to share my analysis of this groundbreaking research on detecting personal information, PI, leaks in mobile health apps. The authors have made a significant contribution to the field by developing a novel approach that sheds light on a critical issue affecting millions of users worldwide. The paper shows that the authors achieved a remarkable feat by pinpointing a major flaw in the current state of mobile health app security. Specifically, their study reveals that third-party leaks are 5 times more frequent than first-party leaks, and most of these breaches occur to local storage rather than network destinations. This finding is particularly striking, as it highlights the often overlooked vulnerabilities within apps themselves. This research demonstrates a crucial aspect of the problem. The sheer scale of PI leaks in mobile health apps is staggering. The author's analysis reveals that the typical app has 1 first-party leak and 5 third-party leaks, underscoring the importance of addressing this issue. Furthermore, their study highlights the significance of detecting these leaks, as they can be misused by malicious actors to exploit sensitive user data. The paper also underscores the need for more stringent regulations and industry-wide standards for mobile health app security. As data is routinely sent to advertisers and stored in the cloud where it can be accessed by unauthorized parties, this research serves as a wake-up call for developers, policymakers, and users alike. In conclusion, this research has far-reaching implications that extend beyond the realm of mobile health apps. It sets a new benchmark for security standards in the tech industry and underscores the importance of protecting user data. The author's innovative approach to detecting PI leaks will undoubtedly influence future research and development in this area. As we move forward, I predict that this study will inspire a wave of innovation in mobile app security, driving the creation of more secure and trustworthy digital ecosystems for users worldwide.
Fascinating perspective from Dr. Now let's hear Professor Marcus W.'s analysis of this research.
The paper in question attempts to draw conclusions about the security vulnerabilities of medical apps compared to health and fitness apps, specifically regarding personal identifiable information, PI, leaks. While the topic is certainly timely and relevant, I must express some measured skepticism regarding the claims made. Firstly, the authors claim that medical apps have 20% more PI leaks than health and fitness apps due to collecting sensitive health data is intriguing, but it relies on a weak evidence base. The paper's statistical analysis appears to be limited in scope and does not account for potential confounding variables, which raises concerns about its validity. Furthermore, I believe the author's approach may be overly complex, leading to overfitting of the data and poor generalizability. Their categorization method, which groups PI into 16 types, seems arbitrary and lacks a clear theoretical foundation. This lack of rigor makes it difficult to assess the robustness and reliability of their results. Moreover, the paper fails to provide a thorough validation process for their categorization approach. Without a rigorous evaluation of its effectiveness, we cannot be confident in the accuracy of their conclusions. This omission is particularly concerning given the sensitive nature of the data being analyzed. To move forward, I would need to see a more comprehensive statistical analysis that accounts for potential confounding variables and a thorough validation process for the categorization approach. Additionally, the authors should provide a clear explanation for why they chose this particular grouping system and how it relates to established security frameworks in the field of mobile app security. Ultimately, convincing me would require a more nuanced understanding of the complexities involved in analyzing PI leaks in medical apps. The evidence presented must be robust, thorough, and transparent, addressing each of these concerns and providing a clear justification for their methods and conclusions. Only then can we have confidence in the validity of this research.
And with that, we conclude today's Research Rundown episode. As our debate comes to a close, it's clear that Dr. S' enthusiasm for the potential breakthrough in this field is matched only by Professor S' concerns about the methodology and evidence presented. Sees great promise in this research. Professor S' skepticism serves as an important reminder of the rigor required to validate such claims. Both perspectives have merit, and it's not uncommon for cutting-edge research to spark lively debates like this one. We appreciate both Doctor for engaging in a thoughtful and respectful discussion with us today. Their insights will undoubtedly add value to our listeners' understanding of this topic. Thank you to all who joined us on this episode, and we'll be back next time with more research rundowns.